Welcome guys to interpretation of graphs for motion along a straight line. Now, when an object is having a straight line motion, there are different physical quantities that come into picture, like how much is the distance traveled and in what duration is the distance traveled, how much is the displacement, how much is the velocity, is the motion uniform motion or non-uniform motion. So, using plotting a graph of distance versus time or velocity versus time, it is going to give us number of information about the motion of the graph. But before we actually interpret the graph or learn to interpret the graph, we'll first understand what is the relation between angle and slope of a line. So let's get started. So let's first understand the graph. Now when we plot a graph on the y-axis, we have a vertical line which is called as y-axis and a horizontal line which is called as x-axis. So this becomes the x-axis and this becomes the y-axis. Now when we are talking about motion, okay, so distance or displacement, velocity, acceleration, these all physical quantities are plotted along the y-axis. And along the x-axis is the time. Usually along the y-axis we have physical quantities which depend on the x-axis. Whereas x-axis of whatever physical quantities, it is independent. So time is an independent physical quantity, right? So we will always have in motion time on the x-axis. Whereas other physical quantities like distance, displacement, velocity, acceleration are always on the y-axis. Now let's understand how do we find the slope of a straight line. Okay. Now suppose we have a straight line like this. Say this is line L and we have another straight line which is M. Okay. Now this line L makes angle theta 1, some angle theta 1 with the x-axis. Now this angle is always measured with positive direction of x-axis. And line M is making angle theta 2 with respect to x-axis. Now in this case we say slope of M is greater than slope of line L, right? Because here you can understand this line is more steeper, line M is more steeper, hence it is having greater slope, whereas this is a gentle. So if suppose you were to climb this, climbing this wouldn't be difficult, whereas climbing this would become difficult. So here we say it is a steep slope and here it is a gentle slope. So always steeper slope will be for a greater angle. Gentle slope means smaller angle. Now when we want to find the slope, okay, say now suppose this line L, if we are finding a slope of this line. Right now if we are comparing these two lines M and L, we know this is having greater slope than this line L because its angle is greater. Okay. Now we are supposed to find the actual value of the slope. How much is the slope? In that case, what do we do? Suppose for line L, we want to find the slope. How much is the slope? We consider any 2 points on this line. Say this is point here and one point here. Okay. Now coordinates for this point is what? X1 and Y1. Right. We always write X coordinate first and then we write the Y coordinate. Right. So this is x1, y1, and for this point this becomes y2 and this becomes x2, right? So you consider any 2 points on the line. For a line where whatever points you will consider, whichever points you will consider, any 2 points on the line will always should give the same slope because this angle will be same. If I draw a line here, this angle will also be theta 1, this angle will also be theta 1, right? So if we want to find the value of the slope, we consider any 2 points on the slope, find its coordinate. So here x1, y1 and here x2, y2. Let me erase this so it will make more clear. Now we understood what that if the angle increases, that means the value of the slope will increase. Okay, so this is our y axis and this is x axis, right? Now we want to find the slope of this line. This is some angle theta 1. Okay, as I said, you consider any 2 points on this line. So if the let the coordinates of this be x1 y1 and x2 y2 for this point. Okay, of course this is x1, this is x2, and then these are y1 and y2, right? Now we want to find the slope of this, right? So slope, how do we find? It is y2 minus y1 upon x2 minus x1. So this y2 minus y1 means what? This y2 minus y1. So if this is angle theta, right? So this will become the opposite side for that angle, and x2 minus x1. So this becomes the adjacent side, right? So slope is what basically, so slope, the symbol is small m, opposite upon adjacent. Now in trigonometry this becomes tan theta. So finding tan of that angle will give us the slope, or just we can say the change in the y coordinates upon change in x coordinates gives us the slope. So this is how we find the slope. Hope this is clear. So same thing I have briefed on this slide. Slope of a graph here, as the angle increases, slope increases. So theta 1, this angle will have smaller slope compared to this line, right? Angle is measured with respect to positive x-axis. Angle is less than 90, the slope will be positive. Yes, if this angle is less than 90, then whatever slope we get, that will be always positive. But suppose if you had a line like this, now this angle is greater than 90. So for such line, the slope will be a negative slope. This you remember. Okay. Now how do you find the slope? It is y2 minus y1 upon x2 minus x1, or we say change in y coordinates upon change in x coordinates. So change in y is basically the opposite side for that angle, and change in x is the adjacent side. So we say opposite upon adjacent, which is tan theta in terms of trigonometry. So basically when we want to find the slope, we have to find tan of that angle. That will give us the slope. Okay, and if we don't know trigonometry, then simple y2 minus y1, take any two coordinates on the line, any 2 points on the line, find its coordinates, and then take the difference in the points and divide it. So opposite upon adjacent, change in y upon change in x coordinates. And then other thing is finding area or region under the graph. That is depends upon the shape of the graph. Okay, we'll see later. But when we want to find the area or region, it is usually multiplication of the y and the x, change in y into change in x coordinates. So delta y into delta x. But once again, it depends upon the shape of the region, shape of the area. It is usually triangle, square or rectangle. Hope it's clear. So now let's understand some basic terms before we actually proceed to the interpretation of the graphs. Now let's revise some common terms. First is distance. Distance is the actual path traveled by the object, and distance is a scalar quantity. Scalar means it has to do only with the numbers. There is no need of direction. So when we are talking about some object which goes from position A, say this is position A, to some position B. Now what is the path the object takes, that becomes the distance. Suppose now the object travels like this, and then it goes this distance, and then it goes this distance. Okay, so this becomes the actual path traveled by the object from here like this. So this is the total distance traveled by the object, and it is a scalar quantity. It has nothing to do with direction. Now next is displacement. Displacement is the shortest distance between initial and final position. Now in this case, shortest distance will be what? The straight line between the initial and final position. So this, how much the object is displaced, how much the object is displaced with respect to its initial position, that becomes the displacement. So this is the displacement. Displacement is the shortest distance between initial and final position, and it is a vector quantity, because when we are saying displacement, we have to specify in which direction that shortest distance is, right? So here in this case we can say the object is displaced by 50 meters to the right side of A. Okay, like that we have to specify the direction along with the magnitude. Then that becomes the displacement. Hence displacement is a vector quantity. Now SI units of distance and displacement is meter. If the motion of object is to and fro, then distance and displacement will be different. Now consider this case. Okay, say the object is here, starting point. It has traveled this distance, it has reached B, and then again from B it travels backwards and reaches some point C. So in this case, the total distance traveled by the object will be this plus this. Right, this becomes the total distance because it is to and fro motion. However, displacement will be what? Displacement is the shortest distance between initial and final position. This is the final position, this is the initial position. So the shortest distance between initial and final position, this becomes displacement. So here in this case, distance is this plus this, whereas displacement is this, right? So here, because the object is moving to and fro, coming back, distance and displacement are different. But if it would have been a straight motion, there is no returning of the object is moving in forward direction. Okay, in that case distance and displacement will be same. This you need to understand. So if, however, the motion is straightforward, then distance and displacement are same. Now next is speed. Speed is what? The total distance traveled upon time. So whatever path is taken, distance means what? Whatever path is taken by the object, that is the distance. So distance upon time will give the speed, and it is a scalar quantity because distance has nothing to do with direction, neither has time. So this becomes a scalar quantity. Next is velocity. When we specify speed along with direction, when we say 25 kilometers per hour to the east direction or right side of the school or home, whatever, when we are specifying direction along with speed, then it is a vector quantity. So velocity is speed with direction and velocity is a vector quantity. SI units of speed and velocity are same, that is meters per second. Now for velocity, the upward direction is positive and downward direction is negative. Now this you need to understand and remember. This is true or valid for a ball. This example usually they give ball thrown upwards. Okay, now the ball is thrown upwards, so continuously its displacement is increasing, right? So in that case velocity will be positive. Now a ball coming downwards, now its displacement with respect to original position is decreasing, so it is negative, and hence velocity will be a negative value when we are talking about downward direction. So for velocity, the upward direction is positive and downward direction is negative. Next, if the velocity of an object changes from initial value u to final value v in time t, then the motion is accelerated. If there is change in velocity of the object, then we say the motion is accelerated, or we can say acceleration is change in velocity upon time. V minus u by t is acceleration, change in velocity upon time. Now SI unit of acceleration is meters per second square. Here velocity is meters per second and divided by time, so it is meters per second square, SI unit of acceleration. Now if the acceleration is in the direction of velocity, it is positive. Best example is when the car is starting from rest, right? So when the car is starting from rest, initially its velocity is u, slowly its velocity increases. That means its acceleration is positive. If the acceleration is opposite to direction of velocity, then it is negative. Car coming to rest. Example, when the car is coming to rest means initially its velocity was high and now it is coming to 0. So we say the body is accelerated, but it is now negative acceleration. So acceleration has to do with the direction as well as the magnitude of the velocity. Hence acceleration is a vector quantity. Acceleration is change in velocity upon time. Now this change in velocity, it will be v minus u upon t, depending upon this v, whether it is greater than initial velocity or lower than initial velocity, we will have plus or minus sign, and accordingly we say body is having positive acceleration or negative acceleration. So initially when the car is starting from rest, u is 0, so it is positive acceleration. When the car is coming to rest, that means final velocity is 0, so in this case it is negative acceleration. Hope this is clear. Now there are types of acceleration: uniform acceleration and non-uniform acceleration. Uniform means what? If the object travels in a straight line and its velocity increases or decreases by equal amounts in equal intervals of time, then it is uniform acceleration. So velocity is increasing or it is decreasing, but it is increasing or decreasing in equal amounts, whatever amounts, say 25 kilometers per hour. It is increasing every hour by the same value, same magnitude, or decreasing by same magnitude, then it is uniform acceleration. Otherwise it is non-uniform acceleration. That means if the object travels in straight line and its velocity increases or decreases by unequal amounts in equal intervals of time, then it is non-uniform acceleration, right? Like for first 1 hour it is increasing by 25 kilometers per hour. Next 1 hour it is increasing by 50 kilometers per hour. Okay, so this is non-uniform acceleration because the object is traveling with varying velocity with equal intervals of time. Hence it is non-uniform acceleration. Now we'll go to different types of graphs. First let's start with graphs. Okay, let's start with distance time graph. Now we know distance is equal to speed into time. This formula we are well aware of. Distance is speed into time. So let's see our first graph. Now this graph is given to you. What can you interpret from this graph is, on the y-axis, as I told, we have all quantities which are dependent on time on the y-axis. So x-axis is time and y-axis is distance, velocity, acceleration will come on the y-axis. This is called as y-axis, this is called as x-axis. So now here it is distance on y and time on x. Here we are seeing this, and this becomes the origin. Okay, this is called, this point of intersection is called as origin, which have coordinates 0, 0. Means 0 time, 0 distance. Okay, now here what it means, you have a line parallel to the time axis. That means as the time is increasing, the distance is constant, whatever it is, say 50 kilometers or 50 meters or 25, whatever. But the distance remains same irrespective of time. That means time is increasing, but the distance is same. Which means what? It means the object is not moving. The object is at rest. So here, as time increases, distance covered remains same. Implies the object is not moving. It is stationary or at rest. So this is one type of plot, distance versus time, where distance is not changing. Distance is same throughout and time is increasing, means the object or the body is at rest. Now this case, distance versus time. Here what we see? Here we see that as time progresses, distance also increases. With increase in time, distance is also increasing. This could have been like this also. Like this plot also I can show, or like this also I can show. Okay. All these straight line graphs means that the object is moving with uniform speed. Now why speed? Why we are calling it speed? Because here if you find the slope of this line, how do you find the slope? How do you find the slope? You take any 2 points on this line. Okay. Find its coordinate. Here it is x2, y2. Here it is x1, y1. And when you find the slope, it will be what? y2 minus y1 upon x2 minus x1. And what is y2 minus y1? It is this distance. This distance upon this time, change in time. So this is delta t. So change in time and change in distance. That is our speed. Distance upon time is speed, right? This distance upon time will be speed. So distance versus time plot will give us, the slope will give us the speed of the object. Here we will say the object is moving with uniform speed. So as time increases, the distance is also increasing in same proportion, implies the object is moving with uniform speed, or the object is having uniform motion. Now observe this plot and this plot. Okay, if these are the plots given to you, what can you interpret from this? First is the thing that you observe, it is distance versus time. Both the things are distance versus time. So the slope will be the velocity. Distance upon time will give us the velocity. So our slope, whatever we'll get, will be the velocity. But here, how do you find the slope? So in such curved figures, you have to draw a tangent at a point. Okay. Now suppose I am drawing a tangent here at this point. Okay. So this angle is my theta 1. Okay. And I am drawing a tangent at this point. So this is theta 2. Now clearly theta 1 is less than theta 2, right? Theta 1 is less than theta 2 means what? Theta is the slope, velocity. Velocity 1 will be less than velocity 2. The slope, initial slope is less than the second slope. So we say the object is moving with a increasing velocity. In this case, the object is moving with increasing velocity. Similarly here, if you draw a tangent to this, say here if we draw a tangent, this is theta 1, and if you draw a tangent here, this is theta 2. So here clearly theta 1 is greater than theta 2, and these are the slopes. So v1 is greater than v2. So here we say now velocity is increasing with time, right? So this all information you can get from the graph. So here object covers unequal distances in equal intervals of time, and it is non-uniform motion. For uniform motion we know it has to be a straight line. Here this is non-uniform motion, because of which it is a curve. If the motion is a uniform motion, then it will always be a straight line like this. It has to be a straight line. It can be this straight or it can be this straight, or it can be this straight, which means it is a uniform motion. Object covers equal distances in equal intervals of time. If the plot is bending curve, that means it is a non-uniform motion where the object is having variable speed. Now one more type of graph you can have for your exam. This is distance versus time. Now what does this graph say is that at particular time, say t1, the object is continuously moving at one particular time, say at 3 p.m. in the afternoon, the object is continuously increasing its distance at one particular time. Now, what does this mean? Time remains same, but distance keeps on increasing. Implies the object is moving with continuously increasing velocity at a fixed rate. So, such motion is not possible. This is not an ideal or a practical case. But if such graph is given, what it means is that object is continuously moving at one particular time with increasing speed. Now let's understand velocity time plots. In velocity time plots, we will have velocity on the y-axis and time on the x-axis. Right, so here the first graph, we are seeing the velocity is constant throughout. The velocity is not changing. The time is increasing, but the velocity is not increasing. The object is moving with same velocity throughout. This is a case of uniform motion. Here we say time is increasing, but velocity remains the same. Implies the object is moving with constant velocity, or the motion is uniform motion. The acceleration in this case is 0 because there is no change in velocity. Velocity is constant. And what is acceleration? Is the rate of change of velocity. By what rate the velocity is changing. Here velocity is not changing. Velocity is constant. Hence acceleration is 0. Now next case, velocity versus time, where velocity is increasing with time. Now this is a case, straight line graph. So it is a case of uniform motion. Here it is uniform acceleration. And how do you find acceleration? By finding the slope of this line. Now this is a positive slope. Angle will be positive with respect to the x-axis, right? So here velocity is increasing by equal magnitude in equal intervals of time, implies the object is moving with uniform acceleration. Once you find the slope of this graph, you will get acceleration, which will be uniform acceleration. So we say uniformly accelerated motion. Here the slope is positive, acceleration will be positive. Now next case, velocity versus time. Now this plot is like this. As time increases, the velocity is decreasing. Now what can you say? Velocity is decreasing with time means what? It is retardation. Velocity is decreasing with increase in time. So negative acceleration or retardation. That means at regular intervals of time, the decrease in velocity is same in magnitude. So uniform retardation. Now in this case, we can say that it is a negative slope. So we will have a value as negative, or we see it as retardation. So uniformly decelerated motion. Slope is negative. You will get negative slope. And as I have told earlier, if this angle with respect to x-axis, if this angle is greater than 90, then the slope will be negative. In this case, velocity upon time, that is acceleration. So acceleration is negative. That means it is retardation. Now one more case. This is again velocity versus time. Now here it is not a straight line. So it is a non-uniformly accelerated motion. Velocity is increasing with time, but it is not uniform increase in velocity. Hence, this is non-uniformly accelerated motion. Object moves with varying velocity at equal intervals of time. So it is non-uniformly accelerated motion. Now whether the acceleration is increasing or decreasing, that you can find by finding the slope at 2 points. Say here, if you find the slope at this point and at this point. So when you find the slope at 2 points, and then you can talk about the acceleration, because rate in change in velocity is acceleration. So y-axis is velocity, x-axis is time. So change in velocity y, delta y upon delta t will give you acceleration. So you can compare this and find for yourself. Do put in the comment box. Now let's understand with one example. A ball is thrown vertically upwards. Which would be the velocity time graph for the ball? Now first observe the plots. Okay, velocity time graph is given to us for the ball. So which of this do you think will be correct for our case? So first case, it is velocity is coming to 0, then again it is increasing with time. Okay. B case, velocity is coming to 0 and it is decreasing, but in reverse, with reverse of time. We cannot reverse the time. So B option gone. Similarly, C option, you cannot have reverse direction. Velocity is coming decreasing, but time is also decreasing. It not possible. So B and C are out of question. They are not possible. Between A and D is the confusion. Now velocity here is decreasing with time. It becomes 0 and then it increases when it is coming down. So here we know, as the ball is coming downwards, its velocity has to be negative. So this should be the case. So correct option should be D, because here velocity is decreasing with time. It becomes 0 and then while coming down it is becoming negative. So correct option is D. So one more example we can have. In the following graph, find the total displacement of the object during the time interval when there is non-zero acceleration and retardation. So now non-zero acceleration means in this region they want you to find the displacement. That means this and this region. So this region, this whole region is a non-zero acceleration and retardation. This is a constant velocity. This is constant velocity. So zero acceleration, right? So non-zero acceleration is this and retardation, right? So this shape you can divide into two, a rectangle and a triangle. So find the area of rectangle and triangle, and that will give you the total displacement of the object. So simple. Do put down into the comment box whatever is your answer. I hope I have managed to make interpretation of graph simple for you. Do watch the video twice, thrice, so that your ideas and concepts will be clear. That's all in this video. Do like, share, subscribe and hit the bell icon for more such videos. Thank you.